All right, so this is whole supply chain number 2. Again, my name is Paul Lorenzo, and today I will be sharing my understanding on of a situational problem in supply chain management, specifically concerning the use of buyback contracts in a book supply scenario. All right, so a publisher sells books to boarders at $12 each. Boarders purchase the book at $24 and expects demand to be normally distributed with a mean of 20,000 and a standard deviation of 5,000. So Borders places a single order with the publisher. Currently Borders discount and unsold books down to $3, and any unsold books at this sale price, the marginal production cost for the publisher is $1 per book. Let me just check if I'm recording. All right. So the border discounts any unsold book. All right. So the marginal production cost for the publisher is $1 per book. So we have questions to be answered. A, how many books border should order? What is their expected profit? How many books are expected to be sold at a discounted price? And number two, what is the profits published? What is the publisher's profit given to Borders actions? And then we have to look for the following. Number one, I think, is the books. How many books should be ordered? What is the Borders expected profit? How many books are expected to remain unsold? What is the publisher's expected profit? And what should the publishers do? So let's do part A first, or at least question A. All right, so you're gonna see here inputs. So our mean and demand is always 20,000. Standard deviation is 5,000. So our Borders cost is $12, like in the problem. Border sale price is $24, and then the salvage value is G, and then the publisher's cost is 1, and the publisher's sales price to Borders is 12, and then we have no buyback in this current scenario that we have. So step number 1, we have to calculate the cost. So again, the cost of understocking and overstocking. So the formula same still applies. So price minus cost should be 24 minus 12 is 12. And then the cost of overstocking, as you can see in the formula, is cost minus the salvage value, which is $3. So we have 12 minus 3 is 9. And then step number two, we have to determine the optimal order quantity. So we have to use the critical ratio in the new vendors model. Or sorry, news vendor model. So in order to do that, to compute for the service level, we have to get the cost of understocking divided by the sum of understocking and overstocking. So 12 plus 9 is 9, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 12 divided by 21 is 0.571. Using the inverse normal distribution with the mean of 20,000, standard dev of 5,000, and probability of 0.571, we get the optimal order quantity of 20,900 books, or the order size. So what's step 3? What's next? So in step 3, the expected overstock and understock, the expected overstock should be around 2,477 books. And then for the understock, you're gonna see here, we're gonna have 1,577 books. So these were computed using the news vendor expected loss functions involving the normal distribution. All right, so let's go for the final step. What is our expected profit? So you're gonna see here, our Borders expected profit will run around 8,784. So how do we get the publisher's expected profit? So here, you're going to see, the Borders expected profit is 198,784. So for the publisher's expected profit, the order quantity times the sales price to Borders minus the production cost, you're gonna see here in the formula, times 12 minus 1 will be equal to 229,901. So that's their profit. And then the total supply chain profit will gain around 428,685 if you add the two here. So the border's expected profit together, 428,685. All right, so let's move on to scenario 2. What about with buyback contract? So a new plan under discussion here is that the publisher refunds the border of $5 per unsold books, and the borders continues to discount unsold books to $3. So what happens next? Let's double check. All right, so the updated inputs we have here, border salvage value will be 8 because 3 plus 5 is 8. And then the border's cost would still be 12. So we have to compute for the understocking and the overstocking values. So for the understocking values, we have here C18 minus C17, this two. So 24 minus 12 is 12. And then 12 minus 8, which is salvage value. Cost minus salvage value is 4. So that's that. So step 1, again, we have to find the new critical ratio. So how do we do that? So the cost of understocking divided by the sum of the cost of understocking and cost of overstocking. So that's 12 divided by the addition, the sum of 12 plus 4. So that is 0.75. So we have to input this into the new inverse function, normal function. So with the mean 20,000 and the standard deviation of 5,000, the new optimal order quantity was 23,372 for the order size or borders oversize. So what is our expected overstock and understock? So here, if we put it to the normal distribution, we will get an expected overstock of 4,118 books. And then for the understock, it's just 746 books. Now, step 3, the updated profit. So the border's expected profit is 24,578. Sorry, 214,578. And then the publisher's expected profit should be order quantity times 12 minus 1, or the subtraction of 12 minus 1 is equal to 236,506. So what's the formula for that? If we took a look at the formula here, take a look at the formula, you're gonna see here buyback refund times the unsold quantity is equal to 23,372 times 11 minus 5 times 4 times 18, 118. Sorry, 5 times 4,011, 4,118, that will be equal to 236,506. And then the total supply chain profit would be 24,578. Sorry, 214,000 plus 214,578 plus 236 will give us the total supply chain profit of 451,884. Sorry. So the final answers to the question. So let's go on the top here. Let's answer their questions. All right. So first things first. How many books should the borders order? They should order, number 1 here, of course. Sorry, let me just copy paste that. So this will be my computation for both no buyback and buyback contracts. So why are worksheet structures this way? I think the Excel sheets follow the news vendors model because it allows us to calculate the optimal order quantity, order certainty. We need to analyze profit trade-offs between understocking and overstocking. So it will also enable us to determine how a buyback contract affects behavior and profitability for both parties by comparing scenarios with and without buyback. The model shows how risk-sharing contracts can benefit the entire supply chain. So in terms of reflection and I think real-world application, this lesson can be applied to businesses like our printing company. My family is a business. Because just like printing books or at least printing calendars like the one in the example for the transportation, the demand for uh, this type of outputs or products fluctuates with the market conditions. Overstocking results in like storage costs, while understocking leads to lost sales. So, using a similar model, the company can determine an optimal purchase quantity. They can also implement a buyback arrangement with certain clients. Like, for example, repurchasing unsold stickers at a certain restaurant that needs labels for their packaging. So, this approach would actually, number one, reduce the financial risk rather, encourage bulk purchasing, improve supply chain efficiency, and then minimize waste. And that concludes my presentation. Thank you all for listening. I hope this walkthrough would give you a helpful insights into supply chain decision making. All right, thank you so much. Have a good one.